Okay, let's just dive right into this explainer by shattering everything you thought you knew about our allegedly perfect little planet. We love to think of Earth as an absolute paradise, right? But looking at the actual data, it's actually kind of mid. Seriously, huge portions of our globe are completely covered by totally hostile deserts of ice, blinding fire, barren rock, or just permanent darkness. So what if there was a planet out there that wasn't just suitable for life, but mathematically ideal? A place so bursting with biomass and biodiversity that our green Earth would literally look like a barren wasteland in comparison.
Well, to build a truly perfect world, we actually have to start at the center of the solar system. We love to think of our yellow dwarf star as this ultimate, comforting giver of life. But the reality? It's a much more terrifying story. The sun is a ticking time bomb. It'll die in under 10 billion years, and it's constantly getting hotter and hotter as it ages. Think about this for a second. 70% of the window for life on Earth has already passed. In just a mere couple of billion years, the sun's going to heat up so much that it'll end all life here. Period.
So, this brings like a pretty stark contrast between our heavily flawed star and the true perfect star for life. Red dwarfs, which actually make up most stars out there, live forever, but they shoot out this deadly radiation that just sterilizes planets. And yellow dwarfs, like ours, they burn out way too fast. But smack in the Goldilocks zone between them, you've got the orange dwarf. Their energy output is remarkably stable, the radiation levels are far safer, and their lifespan is simply unbelievable compared to our sun.
70 billion years. That's a 7 with 10 zeros. An orange dwarf provides an astonishing 70 billion year window of stability. That basically gives biology roughly 7 times more time to emerge, to evolve, and to thrive than our sun could ever hope to provide. So if we want to imagine the absolute peak of planetary real estate, we have to put it in orbit around one of these super calm, perfectly stable orange giants.
And if we place a perfect planet around that perfect orange dwarf, we get Hestia. Named after the Greek goddess of the comfy home, Hestia is a theoretical, superhabitable super-Earth. Because its radius is about 1.3 times larger than Earth's, it boasts a massive 70% more surface area. That is an incredible amount of extra space for life to spread out. Now, with almost twice Earth's mass, you would feel about 20% heavier walking around on it, but the sheer real estate it offers makes Earth look like a tiny, cramped studio apartment.
But you know, all that space means absolutely nothing if the planet is just a dead rock. Before life can even start to bloom, Hestia needs 2 very specific geological foundations.